Hello out there. I hope you're excited out there and have some energy to go with the maths. And remember, doing your mathematics doesn't mean observing. Yes, there's some observing, but you need a pen and paper and have your calculator there and try some of the problem. I mean, when you go on break, think about some of the questions. That's a very important part of learning. So we'll explore the measure of central tendency and the dispersion of data. Fantastic. Let's see what we have for you today. So, have you ever thought about this? Very important. How can an investment company calculate risk? Very interesting. How do you calculate risk? What does risk mean? What does it mean to you? Risk, yes, is the worst that can happen to the corporation. Can be something like that. If we look at your money, can you lose it? What is the chance of losing that? So today, or maybe at some later time, we'll actually, if we don't touch on what risk means, is actually the deviation from average, deviation from mean, too much movement. That's high risk. Some of you might have heard of something called volatility, okay, which is actually a risk. So much high deviation from the mean, which we'll actually discuss also today and when we look at the measure of dispersion. Okay. So before we do that, so we'll look at the 5-number summary, the box and whisker. So, but under our measure of central tendency, okay, remember central tendency, you tend towards the center of the data, okay, which are quartiles. Quartiles is 25% of the data, is that the median, the middle one, and the middle of the last 50% of the data. Then the average, which is the mean, also. The measure of dispersion, how the data is scattered, is the range, interquartile range. Okay. And remember that the interquartile range is the upper quartile minus the lower quartile. Okay. Now, some of the keywords: raw data, group data. Raw data, it's like 1, 2, 3, 4, 5, 6, something like that. That is raw data. But grouped data is when data is grouped according to class interval with tally or frequency. And remember, frequency is the total within that interval. Are we all together? Raw data, random numbers, grouped is grouped with class interval, tallies, and frequency. Then we'll look at some keywords: extreme value and skewed. Extreme values are the highest or the lowest value on a set of data. Be together. This can be the minimum or the lowest. Those are the extreme value. Okay. They can affect your average, which is the average, which is the same as the mean. So when we talk about skew, we talk about whether your data is to the left, to the right, or is symmetric. The side of the data is the same as the side of the data. But we'll use the Whisker plot to explore that. Okay. Then this is our measure of dispersion, quartiles, average, measure of dispersion range, interquartile range. Let's start with average. All measure of central tendency. 3 average in statistics. We have mean, median, and mode. Those are average: mean, median, and mode. Are we all together? Mean is the average, median is the middle one in the data, mode is the most occurring one. Okay. So those are the averages. Mean is known as average. To find the mean value of set of data, which is the numbers we have, you add all the data value, then divide by how many they are there. Okay. Okay, so this data shows the population in millions of a random sample of 12 countries. So what you have to do is to find the mean population of 12 countries. So what it means, this is 3.6 million, 5.8 million, which is another country. Where do you think South Africa actually falls? Any idea? Are we a population of 3.6, 5.8? I think we somewhere there, around 50-something million. Okay, let's carry on and calculate the mean for 12 country population. So to do that, we have to add all the number divided by 12 because we're working with 12 countries. So how do we do that? We add all the numbers from 3.6 all the way to 5.6 divided by 12. Use a calculator, and if you add all the numbers on top, you get, that's what we get, divided by 12, and our mean is 23.78 million. That's the average of the 12 random country. Okay, now let's look at the range. So the range is the maximum value minus the minimum value, the highest minus the lowest. What is the highest? The highest is 125.6 minus 2.5, which is the lowest country with the smallest population from 12 countries. And if you minus them, we get 123.1 million people, which is the range. So this is the data we had. We had our mean, which we calculated it, happy with that, and our range, which is what we got. Okay, which is the repeat. Okay, our mean. So now, let's look at the estimated mean of grouped data. So what we had raw data, the actual data given to us. We knew this country, the population was 3.6 million. We knew that this country population was 50-something million. But what if data is grouped in a table? How do we calculate the mean? Let's look at how we do that. So we call this an estimated mean. And why do we call this an estimated mean? It's not the actual mean, it's an estimate. Okay? And we'll discuss how we can actually improve the accuracy of this estimated mean. So, an estimate for the mean can be obtained by assuming that each of the raw data value takes the midpoint, the middle of the interval in which it has been placed. So the mean is the sum of all frequency times the midpoint divided by the total number of frequency. This sign, it just means sum. Add, this means sum. Sum is the same as add. This is F, which is F is for frequency, X is the midpoint. Over F, that sign, which is called sigma, it means add. Let's look at an actual example. This is the data, actual data obtained, okay? So it's grouped for us according to age and actually the frequencies. the number of coronavirus, the COVID-19 death in South Africa in 2020 by age. The number of deaths is shown in the grouped frequency tables. What it means, this is the age, okay? And how many people actually died from COVID-19? It's 8. The age, which is 20 to 40, people died from COVID-19. 40 to 60, 715 died from COVID-19. 60 to 80, okay. And 80 to 100, that's the size. And total number of people died from COVID-19 is that 1891. Okay. This is not like the whole year. It's for a certain period. This could have been collected for 2 weeks, 3 weeks, a month, so on. I'm not sure about when. Okay. But it's probably not the whole year or 2 years. It's for an interval, but it was grouped. Now, to find the midpoint, what we're going to do is we're going to say 0 plus 20 divided by 2. We find the midpoint for them. 0 plus 20 divided by 2, we get 10. That's the midpoint. Then we go 20 plus 40 divided by 2. We get 30. That's the midpoint for this interval. And for the next interval, 40 plus 60, which is 100, divided by 2, we get 50. 60 plus 80 divided by 2, you get 140. And 80 plus 100 divided by 2, we get 90. So now we have the interval, the frequency, the highest midpoint, and the midpoint. The frequency just tells us how many people died in each interval. And we can see the highest is 60 to 80. If you have the age between 60 and 80, the likelihood of dying from COVID-19 very high based on that data. Then what are we going to do? We're going to multiply the midpoint times the frequency. So midpoint times frequency, we get 80. We get 3,420, we timesing this times this. That times that, that's what we're getting. And we're just multiplying them. 848 times 140, that's what we get. And we multiply 90 times 206. Okay. Then from there we add everything. We add 80, we add the number, we add that, we add, and we get the total, which is that. Are we together? Now, what do we have to do? We have to divide the total by the total frequency. Okay. So if we do that, the total divided by frequency, we get 93.34 years. That's the average age of dying from COVID-19. But remember, this is an estimated mean, not an actual mean. But I have a question for you. How can we improve the accuracy of this answer? How can we improve the accuracy of this answer? The best way we can improve the accuracy of answer, what I think, if you look at the groups, you have 0 to 20, so we can make the groups smaller. Look at age group 0 to 10 maybe, 10 to 20, 20 to 30, 30 to 40, and so on. Because if you look at the group, it's just so big. 0 to 20, 20 to 40, 40 to 60, such a big interval. So if we can make the intervals and try to estimate the mean, I'm expecting that mean we can improve the accuracy of the estimated mean of dying from COVID-19. Beautiful, guys. So I hope you make sense. We have looked at the mean, we have looked at the range. For the mean, we looked at grouped and raw data mean. So after that, we'll look at more on statistics. So We'll see you after the break, get some water or something, and come back ready. See you soon. Hello guys, welcome back again. So, hope you're ready. Now, let's see what I have for you. So now, what you're going to look at, you're going to look at the 5-number summary, which are what? What are the 5-number summary? And the 5-number summary actually will come on the Whisker plot. Because to draw the Whisker plot, if you remember, you need the 5-number summary, which is the minimum value, which is the lowest, lower quartile, and median, which is the middle number, and the upper quartile, and the maximum value. Okay? Those are the 5-number summary. Median, which is the middle number, the median value, it can be denoted by Q2. When I say Q2, I'm saying the median. Q2 means the median, the middle number. This is the middle number once the data has been written in order. So we write the data from the smallest to the highest. The middle one is the median, or Q2. Q2 means median. Okay. If there are n numbers in order from the smallest to the highest, the median lies in the position of n plus 1 divided by 2. That will give us the position of the median. The lower quartile, which is Q1, this value lies 1/4 of the way through the ordered data. So also if you want to think about Q1, if you find the median, which is half, so this data, the median is there, then this data is 50% of the data. Then you find the middle of the first half. That will give you the lower quartile, or Q1. When I say Q1 is the lower quartile. Then the upper quartile, which is Q3, lies 3/4 of the way through the distribution data. So we have Q1, Q2. So Q2, remember, is middle of the data. So the last 50% of the data, if I find the median of that, that is Q3, or upper quartile. Okay. Okay, so now the minimum value is one of the number for the Whisker plot, or the 5-number summary. This is the first number once the data has been ordered and written in order from the smallest to the highest. And the maximum value, this is the last number also when the data has been written in order, smallest to the highest. So let's look at this. The 12, this is ordered data, age of 12 bride marrying registry office in the same month in 2015, where this is the data. So what we have to do is to find the 5-number summary. The 5-number summary, so we're going to look at that. Let's look at the data there, which is from 21 to 61. So that is our halfway through. So if you look at Q2, let's do this actually. If you look at Q2, it will be halfway between 6 and 7. So if you look at the data, this is position 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So the median is between there. It's between 28 and 31, which is our Q2. So how do we find Q2? Q2 will be 28 plus 31 divided by 2. It will give us 29.5. Now, to find Q1, we find halfway from there to there, which is between 25 and 25, which is Q1. How do we do that? It's 25 plus 25 divided by 2. Okay, which give us 25. Are we together? Okay. Then the upper quartile, which will be the median from there to there, which is the middle, is between 37 and 43. How do we do that? 37 plus 43 divided by 2, that will give us 40. Then the minimum value and the maximum value is 21 and 61. Okay. Then quartiles, average, measure of dispersion, we'll still look at that. Range, interquartile range. Let's look at the box and whisker. So the box and whisker is just a way of writing the 5-number summary from the smallest to the highest number, okay, which is the minimum value, our Q1, and the minimum value, the median, the middle one, the upper quartile, and the highest value. So this is the whisker plot. We've seen this before with minimum value, Q1, Q3, and the maximum value. This is our whisker plot. So whisker plots are the best, actually useful when we want to compare two sets of data. You can see the location of quartiles, the spread, and the shape of distribution easy when you talk about the distribution easy, whether is the data symmetric to the left or to the right. How do we see that? Another way to see this is, we can see this plot is symmetric. Symmetric, this part, this area is the same as the area. Can you see that? If Q1 minus Q2, Q2 minus Q1 is approximately Q3 minus Q2, your distribution is symmetric, okay? Or by looking at the plot, if that is the same as dot, given that it's drawn to scale. Positive skewed. Skewed, your whisker plot is more into the positive, okay? This is how it looks, it's more into to the right. Where the first one, this part of the block, can you see that? This block is the same as that block, but more is more into the right and less is into the left. Okay, then we can see that also if Q2 minus Q1 is smaller than Q3 minus Q2, we can say this is positive skewed. Are we together? Lastly, negative skewed. You can see is the box after the median. The bigger side of the box is into the left. So this is negative skewed. Or you can check using your quartiles. If Q2 minus Q1, it's bigger than Q3 minus Q2, this is negative skewed. You can draw a box and whisker plot from an ogive. An ogive, remember, is the cumulative frequency curve. Okay. How can we do that? Let's see. So remember, this is a cumulative frequency curve. How do we draw the cumulative frequency curve? Is the end point with the frequency. That's how we draw the cumulative frequency curve. Does that make sense? We all together. We use the endpoints of an interval and the total frequency. We put all the points, then we connect with the solid line. We get the cumulative frequency or ogive. Ogive is the same as cumulative frequency. Now, if you have the cumulative frequency, we can read quartiles from the cumulative frequency. Let's see how we can do that. So the cumulative frequency is from 0 to 60. The middle will be 30. So if 30, we go down, we touch our curve, we go down there. What do we get? We get a number which is 27. Can you see that? So median is 27. How do we get this? From there to there is 60. What is the halfway? Is 30. Then I go there, down, I read that number, and that number is 27. Are we together? Then I go from there, or we can start, find the upper quartile, the quarter of this. From there to there, what is the quarter? The quarter will be somewhere there, 15, quarter of 60. What do? You start from there, touch the graph, the cumulative frequency, go down. What is that value on the x-axis? Remember, this is 20, we know, then this must be 21, approximately 21. Therefore, lower quartile, Q1 is 21. Then 3/4 of 60, maybe somewhere there. Okay, 3/4 from there. You go down, up, touch the curve, down, you read that. So the upper quartile, we get approximately 38. Even if you write approximately 38, that's fine. Then the interquartile range. The interquartile range is the Q3 minus what? Q1. Q1 is the upper quartile minus the lower quartile. The upper quartile is Q3, the lower quartile is Q1. That's how we get the interquartile range. Okay. And the interquartile range, it just talks about 50% of the data. Now we can draw the Whisker plot from that. How do we draw that? The Whisker plot, we have the minimum value, the maximum value, and quartile. Where do I get the maximum value from the cumulative frequency? I mean the cumulative frequency graph, or the ogive, which is the main same thing. So there's the Whisker plot. We have our minimum value, which is 0 there, because that's where the curve starts. And the maximum value, which will be 60, which is where our cumulative frequency ends. That's the max, and that's the minimum value. And we already have the lower quartile, so this is Q1 there, this is Q2, and this is Q3. Okay, can you see that? Already calculated that, our quartiles. Then the nice thing about the Whisker plot, we can able to tell the distribution of the data. Can you see that? We can see this is skewed to the right. I mean, this area is bigger than that area. Does that make sense? This is skewed to the right of the data. Okay, so cumulative frequency, I can get my Whisker plot from cumulative frequency. Okay. So now what I would like us to look at now is to look at the measure of dispersion. When we talk about the measure of dispersion, we're talking about the range. The range, we're talking about the highest minus the lowest value. The interquartile range and the semi-interquartile range. The interquartile range is Q3 minus Q1. Upper quartile minus lower quartile. The semi-interquartile range is just half interquartile range, which is the semi-interquartile range. Okay. So if we look at the range, the highest number and the lowest number can be useful in deciding who is more consistent. The lowest score, subtract from the highest score, that will give us the range. Remember, that the range is not an average, but a measure of spread. Are we together? So the range is the highest minus the lowest. Okay, it's just the measure of spread, how the data spread. Okay. So if the score are spread out, then the range will be higher and score less consistent. Okay. If score are close together, then the range will be lower and the score more consistent. So the range is maximum minus the minimum. Let me make an example. Let's say in a class, you write a math test, and you get all your results back. Then students get 10%, and the students get 100%. So the range of that class will be 100 minus 10, 90. That's a deviation from the lowest mark to the highest. That's the gap between the smallest to the highest, which is 90. But let's look at a test where the lowest mark is 40 and the highest mark 60. If I minus the two, the smallest and the highest, I get 10. So the deviation between, the gap between the lowest and the highest is 10. So there's more consistency in the class. But the other class, 10 to 100, is just so not consistent. So there's high deviation between the smallest and the highest. That's how we look at the range. Okay, so for now, guys, I think we're going to take a short break, okay? Then after the short break, we will look at more and more measure of spread and dispersion under statistics, okay? Great, fantastic. I hope you're having a good time and not observing only. I encourage you to have a pen and paper and to try some of the problems while we're doing them here. Okay, fantastic. See you shortly. Welcome back once again, guys, okay? Let's keep pushing. And remember, to do well is consistency. Is not putting 100 hours or 5 hours on Saturday. It's about that consistency that will get you through. Okay, and I know sometimes when you're doing your maths, it can be difficult. Solving a problem, you have no idea. Okay, but I would say it's persistence that will keep you going. And it's okay in mathematics that you're working on a problem, you have no idea. I think that's the nature of it. What is important is what do you do with the challenge, okay? So look at some of the examples, ask questions, seek help, okay? That's very important. And if you're consistent, you shouldn't be there struggling heavily when it comes to your mathematics. What I mean consistency is that rather than put 30 minutes on a daily basis, not because you're preparing for tests, you're studying to understand what you're doing. And if you start early, you'll definitely do. It will be impossible. You want to cram lots of work in 4 hours because you have an assessment or a test tomorrow. It's really impossible. It's the consistency that will get you through. Okay, great. So we were discussing what is range, and we discussed is one measure of dispersion. And we said range is defined as the maximum minus the minimum value. Okay. I mean, let's say there's a company, and the person who's paid the highest salary in the company minus the lowest, there's a huge deviation. There's a gap. It implies in that company there's inconsistency. But if I go to another company, I go to the guy who's paid more money, minus the lowest, and the difference is not that big. Oh, there's consistency in that. company based on the range. Okay. Good. But range is not the best measure of dispersion. Okay. Are we together? Okay. Good. Let's see what we have now. So here, this data shows the population in millions of a random sample of 12 countries. Find the range of the population size. Okay. What is the range? Okay. Let's look at the range. The range is the maximum minus the minimum. So the range, which is the maximum, what is our maximum? The maximum is that. So it will be actually, that's the maximum value, and we have to minus the minimum value, which is the lowest value. What is the lowest value? The lowest value is 2.5. And if we minus the 2, maximum minus minimum, we get that. That's the range. The highest value minus the lowest value. What does it mean here? Okay, does it mean anything? That doesn't tell us anything. I mean, but if you look at the 125.6, it's kind of an extreme. Are we together? So range might not be the best measure of dispersion because it's very extreme. I mean, it's the biggest. I mean, it doesn't fit within that data set in terms of population. You look at it, you have 3.6 million, 5.8, you know, very close together. Okay, those are very close. Okay, but if you look at that, I mean, it's one of the biggest from that set of data, actually, those two. Are we all together? And that extreme value can actually affect our mean. Okay. If we have to calculate the average because the average is taking everything divided by 12. So the extreme value can affect our average. Okay. So range is not a good measure of spread. That's what I was saying. So the range is not a good measure of spread because one extreme, very, very high or low value can have a bigger effect. Are we all together? Let me go to the example of a company. If I compare salaries, how much people earn from working, and I take the person who earns the highest minus the lowest, and I minus, and I find, there's a huge gap between them. But what if that highest is the only one highest? And I'll say that corporation is inconsistent. But that's not really true. They just have one person earning low and the highest person, and one person earning the highest. But I don't know about the rest of the data. I don't know. So it's not really good because of that extreme value that we might think inconsistency, but actually if we mirror in the middle, we might find that the data is consistent. So if we look at the 5-number summary, this is what we have. Let's look at the interquartile range. So this measure of spread is liked to be the median. So the difference between Q1 and Q3 is the interquartile range. So let's look at the range. The range is the maximum minus the minimum, which give us the interquartile range, which give us the range. But the interquartile range is the Q3 minus Q1, is the range of the middle 50% of the data. And that far better than the range, because the interquartile range is not affected by the extreme values, the high or the lows number, because you're looking at the middle of the data. So that's the difference between Q1 and Q3. And if you look at your box and whisker plot again, so your interquartile range will be from there to there. That will give us our interquartile range. Are we all together? Because that's the difference between there and there, which is the interquartile range. Are we together? But the range, which is actually the max minus min, this is the range. Max minus the minimum value. So this can be one of the extreme value, the max and min, which can have an impact, mislead us about the range. But Q3 and Q1, which is the interquartile range, can actually eliminate those extreme values. Are we all together? Can eliminate those extreme values. Good. So the interquartile range. The interquartile range is generally a better measure of spread because it is not affected by the extreme values. So the interquartile range is not affected by the high and the low number. If I have an argument, somebody argues using range, I don't think it's reliable. I'll rather go with the interquartile range because the interquartile range is not affected by the highs and lows in making arguments or conclusions. Okay. So guys, what we looked at today, we looked at, remember that the measure of central tendency, talking about quartiles, average. We looked at the 5-number summary which goes to the Whisker plot. Then the measure of dispersion, which we looked at the interquartile range, the range, and the semi-interquartile range, which is the half of the interquartile range. That's the semi-interquartile range. So that is actually half of our, you do your Q3 minus Q1 divided by 2. Okay? So the semi-interquartile range. So the semi-interquartile range is half the difference between the upper and the lower quartile. The half difference between the Q1 and Q3. So you can find the interquartile range divided by 2, or half Q3 minus Q1. That will give us the interquartile range, the semi-interquartile. Because it's semi means half, interquartile we know is Q3 minus Q1. The semi-interquartile range is also not affected by extreme value on the score. It is good measure of spread for skew data. Remember, for skew data, skew to the left, skew to the right. So the interquartile range is best for that. So measures of what? Of spread. We had a range, interquartile, interquartile range and semi-interquartile range. We said that the range can be affected by the extreme, high, low, or small. The semi-interquartile range is better because it avoids the extreme, the lows or the highs. But the semi-interquartile range, it also avoids the highs and the lows, but it's good for skewed data. Remember, skewed will be to the left or to the right. So our summary here, what we have looked at today. So we have looked at the measure of central tendency, guys, which means we looked at our quartile, average. Remember, our quartile is Q1, Q2, Q3, which is the same as lower quartile, median, and Q2 the same, and the upper quartile. Then we look at averages, which is mode, agreed, median, and average. We also looked at group data. Then under, we looked at the 5-number summary, which links to the Whisker plot, and the measure of dispersion range, interquartile range, and semi-interquartile range. Great, guys. I think I had great times with you. and hope it makes sense, and keep working hard at home. We hope to see you soon, and this is bye from us.